You are all welcome to the introductory part of number-based system. Because before you have a solid foundation in mathematics, you might have known the number-based system on how to count numbers. I will taught you that in the previous classes. So, and you know place value. So after we are done with the place value, the counting of numbers, we now understand systems at which we count numbers. We can decide to count numbers in base 2, in base 3, in base 4, in base 5, in any base at all. But mathematics use some few systems at which we deal with. Basically, we usually use base 2, which is binary system. We use decimal, which is base 10. We use octa, which is base 8. And we use hexadecimal, which is base 16. So these are the bases we use normally in mathematics. So those bases, base 2, base 8, base 10, base 16 are the basic base we use in mathematics to count numbers. But usually in real life, we use base 10 to count numbers. Base 10 is the basic system we use to count numbers. Like for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think 0, yes. From 0 to 9, that is base 10. That is the usual base we use in mathematics. But in programming, in computer science or computer engineering, or in programming generally, we use basically base 2, which is zeros, 1, zeros, 1, zeros, 1. That is binary. You cannot have more than, it is only 2 digits that we use in binary system, which is only 0 and 1 that are used in binary system, which is in computer programming. So the basic system we use to count number in mathematics or in real life is base 10, which is decimal. Base 10. That is the usual way from 0 to 9. That is the usual way we count number in mathematics or in real life. But in computer programming, we use binary system, which is zeros, 1, zeros, 1, zeros, 1, zeros, 1. That is, in essence, computer does not understand human language. Computer doesn't understand human language. So whenever human beings talk, computer does not understand. So computer has a translator that translates human languages into machine languages. So when the computer translates the human languages into system or into machine language, it converts the human language into binary system in such a way that computer could understand. So computer only understand machine language, which is binary system. So whatever you say in human languages, the computer convert it to machine language in such a way that it could be easy for it to understand. So binary system is used for computer system. People who want to go into computer engineering, people want to go into system engineering, people want to go into computer science or data science, they should pay attention to this. Marvelous. Are you understanding me? So perfect. Since everybody is following, this binary system is used, as I said, is used for computer, and is only zeros, 1, zeros, 1, zeros, 1. You cannot have zeros 2, 0, 3. No. It is zeros and ones, not more than These are the only two digits I use for binary system. But for normal in real life, we count number in decimal system, which is base 10 from 0 to 9. That is the usual way of counting numbers. But we could also use octa system, which is base 8. Here we have 0, 1, 2, 3, 4, 5, 6, 7. In octa system, we have from 0 to 7, and we cannot exceed 8 because the base is 8, so it shouldn't be more than 8. It's from 0 to 7. That is octa system. Then we also have another system, which is hexadecimal system, which is base 16. Hexadecimal system, in this system of numbers, we have from 1 to 9. In hexadecimal system, we have from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, 9. Then A, B, C, D, E, F. That is in hexadecimal. When we reach 9, we use A, B, C, D. This number system is also used for computer. It's used for programming. So in mathematics, this A, usually we use it as 10. We use it as, when we reach here, we now use as decimal. We use this one as 10. We use this one as 11, 12, 13, 14, 15. That is the usual way of handling number base. So I think everybody is following. Number base system is actually the core foundation of mathematics, because before you understand number base, you need to have adequate knowledge of number counting, place value, and number base system. That this is the core foundation of mathematics, and you cannot do without the foundation, because before you know any topic in mathematics, you might have had the basic knowledge of mathematics, which is the number system. So as I explained earlier, we have the 4 fundamental system that we use in mathematics, which is 1, we have the decimal base 10, which is the usual way of counting, the normal way of counting. Secondly, we have the binary system, base 2, which is basically used for machine languages, for computer science, for computer to understand. Then thirdly, we have the octa system, which is base 8. Then lastly, we have the hexadecimal. We have the hexadecimal, which is base 16. Number system we use, but notwithstanding, we can use any base in mathematics. We could use base 3, base 5, base 6, base 7, any base. So having those bases, we can decide to convert from base 10, convert from base 2 to base 10, convert from any base to another base. So we can give you, as we progress, I can give you anything I can give you in base 10 and I will ask you to convert it to base 2, or I can give you base 5 and ask you to convert it from base 5 to base 10. So any base you have it at the back of the mind, at the back of your mind, that it shouldn't be more. Like in base 3, base 3 in base 3 you cannot have more than 3 digits, like 0, 1, 2. These are the only digits that you can find in base 3. 0, 2 and 0, 2, 1 and 0, 1 and 2. These are the only digits you can find in base 3. So you can have any digit, you can have from any base to convert from that base to another base. So we can progress. So understanding number base system is the key in mathematics, and that is the foundation of mathematics. So today we'll be taking only one example, the addition of binary system. As I explained earlier, binary system is the same thing as base 2. That is zeros and ones, zeros and ones, zeros and ones. It is only zeros and ones. So it is not more than zeros and ones. And this binary system, each digit is called a bit, because it is usually short form for binary. So in binary system, we have zeros, 1, zeros, 1, zeros, 1, zeros, 1. You cannot, or 1 0 in any way, but should be 0 and 1. These are the only 2 digits we have in binary. So when you have binary system and you're asked to add, you can add it in the usual way of adding base 10, which is the decimal system. For example, so now the question say we should add Now, the question says we should add 0, 1, 1, 0, 0, 1 and 1, 0, 0, 0, 0, 1. So when you have this kind of question, the arrangement is very important. You need to arrange everything based on column by column. You don't have to jump it. You have to arrange it, starting from the left to the right. You start to the right to the left. So solution in mathematics, this thing is very important. In mathematics, solution is very important. When you have a question, so send solution is the very key thing you need to do first. So when you have it, as we say usual, you have to arrange it column by column. So what you will do now is, we have this 1, 0, 1, 0, 0, 1. We have 1, 2, 3, 4, 5, 6. Let's count this one. 1, 2, 3, 4, 5. So we're starting from this arrangement. We have this one. We now start here, 0 here, 0 here, 0 here, then 1. Then we draw this line here, because you start the arrangement from the right hand side back to the left hand side. So now 1 plus 2, sorry. Now 1 plus 1 is 2. But in binary system, you cannot write 2. Remember, we say in binary system is only 0, 1, 0, 1. So you cannot have 2 as a number in binary system. So the only thing you do, since 1 plus 1 is 2, we are going to divide it because 1 plus 1 is 2. So since we're having base 2, sorry, let's have it base 2. And when you're writing the base, make sure the subscript is down. Is down. It should be smaller than the main number. So since we are handling base 2, we cannot write 2 as a number. So how are we going to do that? As a usual way of adding in base 10, that when you have, for example, let's say for example you have 1 2 2 9 and you're asked to add, in number base 10, when you have this 2 plus 9, that will give you 11, but you cannot write 11 here because it's wrong. So some people say carry 1. How are you carrying that one? No, because you are handling base 10, so you do 10 divided by 11 divided by 10. Since the base is 10, 11 divided by 10 is 1. Remember what? 1. That is why we are carrying that one to the next number. So that one we carry, will bring it here. That is 1 plus 1 is 2 plus 2. That will give us 4. So that is how we do it in binary system too. Since we have 1 plus 1 will give us 2 and the base is 2, we are going to divide 2 by 2. That will give us 1. Remainder is what? 0. That is the remainder we are going to put here. Remember, it's always the remainder. Even here, 11 divided by 11 is 1. 11 divided by 10 is 1. Remainder 1. We take 1 as the remainder we write here. We take the 1, the main number, to the next one. So the same thing applicable here. We have 1 plus 1 is 2. So 2 divided by 2 is 1, remainder 0. So is that 0 you're going to write here? Then we now 0 plus 0 is 0, plus that 1 will give us 1. Remember, since it's not more than 2, then 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, then 1 here is 2. I think everybody understand. So if you understand, subscribe to my channel as we grow together. Thank you.